So this is the reference there. You have a system which is a larger view where people is involved. So I ask you, Max, to try to elaborate or explain what are you seeing here in this diagram. Yeah, take some time to review it.
It shows the interaction between us humans and like the Earth as an ecosystem. And yeah, I mean the upper part is about the actions of the humans, how they interact or how they impact the ecosystem, for example through fishing or any other action that affects the ecosystem. And the lower part shows how we use the ecosystem or what it provides to us. And yeah, it works kind of in a circle that we are given and taking to and from the ecosystems.
Good. So human system is a community, is a country, is a city that take things from ecosystem, either water, air, ground, even us. I mean, this very simple model to show the interaction. Let's say mining. We take some material, we get some material, but put back a lot more. So we take some volume, and then we use more volume in tailing ponds, which is very invasive. Worse of that, with water, it generates some acid drainage that will impact water. So, I mean, we took some little things. Let's imagine 0.5%. Take 0.5% and put more than 99.5% because it's more volume. And more of that also affects aquifers. So that's the point. So how can we do that with less intervention? That's the whole thing. It's a very simple to explain. I like it a lot, so the reference there. However, if you want to go in more detail, you have the real system, and this thing here has a special name. It's called social ecological system. Okay? That explain in more details how this ecosystem interacts. So, I mean, open the boxes. Okay, so you have the ecosystem process, and then you have soil, biotic community, micro environment means to, I mean, imagine all the microorganisms that we have in the sea. So let's say a thermoelectrical plant. Just to, please follow the following thing. You have a thermal plant. You can use either charcoal or methane that comes from a ship. It doesn't matter. You generate heat. You use this heat to generate steam. Steam turbine generate electricity, and then you need to have condensers that take seawater for condense. And okay, you are a mechanical engineer. You understand very well this. And then you take this hot water back to the sea. You increase the temperature, I mean, 4 degrees. You move a lot of, by the way, you move a lot of water in order to not overheat and to avoid incrustations. I mean, scaling in the heat exchangers can be, I mean, cooling towers, doesn't matter. You increase 2 degrees, 2 Celsius, which is nothing. However, as you increase the temperature in the sea, just by this little, you reduce the solubility of oxygen. And this is controlled by the Henry law, which is an exponential with temperature. Just to put some numbers in your head, I mean, at low temperature, 10 degrees, you have 20 milligrams per liter of oxygen. Okay, if you go to 15 degrees, sorry, all the way around. When you have 10 degrees Celsius, you have 20 milligrams per liter of oxygen. If you move to 15, you have 10. So it's exponential. If you have less oxygen, the microorganisms that use oxygen to degrade, they have less nutrient. They have less a chemical reactant, which is oxygen, an oxidant, and then they grow less. If they grow less, the other creatures, I mean, they say plankton doesn't grow. If you don't have plankton, you don't have fishes. If you don't have fishes, you will impact turtles. And this thing happened in Mejillones. With this, we have very, very big plants. I think there are about 6 thermoelectrical plants in the north part of Chile. Not to mention NIX, which is a big plant to generate explosives for the mining industry. Imagine that use ammonia. They also use cooling water system using seawater. The impact was the turtles. And the community, what is saying? I mean, the industry is killing turtles. See how the things are interacted. I mean, you need more time to go through this. I don't pretend to understand completely the things, but just to demonstrate you how the systems are interconnected. For example, regulations. You will see in next chapter, let's say in Chile in 2006, all the smelters, node smelters, to take copper concentrate and generate these copper bars. You generate a lot of SO2 gas, sulfuric oxide, and you generate sulfuric acid. And this concentrate also generate SO2, which is a contaminant gas that generate acid rain, and also generate a lot of arsenic. So policy, state says, all the smelters in Chile will follow a specific regulation. For each plant, they ask for specific emission of arsenic and sulfur. And I said, and this company were forced to invest about 4,000 million US, not for profit, just to reach the commitment of the Chilean regulations. So what I'm trying to say is a variable that is no longer you can skip it. I mean, it's state, and you need to be aware of that. And in order to solve that, you need to put technologies. In this case, it was an adsorbent based on activated carbon. I know the plant. Imagine that. In order just to treat the materials, the gases. This is in Caletones, El Teniente. I have pictures of that I can show you. So they think it's real. Okay? Not to mention, also they need to take care of the slag. Do you know what is the slag? Slag? I mean, when you have a smelter, you know what is a smelter? You melt elements, you have molten metals, and also you have the residue which contains silicates, which is kind of, I mean rocks from the volcano, the same structure. This is called slag. This slag still contains copper, so in order to make the thing efficient, they are not allowed to discharge this slag, so they need to create a new plant to grind this slag and recover the elements. Only because of regulation. Again, if you don't have regulations, if you don't have policy, you're wasting time. Okay, so you need to be connected with policy. You need to show. Okay, even in this region, I mean, politician doesn't know anything about reverse osmosis. I'm coming from the north part of Chile where we do have plants, and they are just understanding. So you need to communicate the technology to teach them. It's your role to do that. Okay. And on top of that, everything is changing. Regional climate, we don't have water, and it will be worse next year, and it will be worse next year. And we need to do something about it. And the alternative is reverse osmosis, for example. Okay, just I want to emphasize how relevant is not only the having technology, also the ability to transfer, and also the ability to communicate to more actors. It's not only technical stuff. You need to communicate to politicians, community. You need to teach, you need to educate. Okay. So, sorry.